Hello, and thanks for clicking on this next Prenarculus production. Today, we're going to be talking about properties of trig, part 2 of our 3-part properties of trig series. Okay, today we're going to be talking about what happens if you work with a point or a ratio that is not on the unit circle. How can you find the trig values for that point? Okay, all right, so there's the spoiler. What happens if you're working with an ordered pair that is not associated with an angle on the unit circle? Okay, so let's start with -6, 8 is a point on the terminal side of angle A in standard position. Find the exact values of the 6 trig functions for A. All right, so let's draw ourselves a little coordinate plane here. And what we're going to do is we're going to go to the point left 6, up 8. So we'll say it's about there. So we'll call this 8. We'll call this -6. Okay. Now, what I want to do is I want to find the exact values of the 6 trig functions for angle A. All right. So now, what I have from standard position is I can draw an angle to here that goes out to this point. Ooh, there we go. Out to this point. Okay. And then the angle that we're going to work with is angle A. All right. So what I can do is I can make a triangle, a poor triangle at that, but I can make a triangle. So there's my triangle. All right. Now, I know on this triangle, I'm going left 6 units on the bottom. So that side is -6. Let me erase this so it doesn't get confusing. And then I'm going up 8 units. So that's 8. The question is, could I find this third side? Sure. I could use the Pythagorean theorem. -6 squared plus 8 squared equals, I'm going to call it r squared. Just call it something. It's like it's a circle. Plus 64 is r squared. R squared is 100. The square root on both sides and put a plus or minus. I get r equals plus or minus 10. Now, here's the deal. The radius, since this is going to be the radius, it has to be positive. The radius cannot be negative. But these two values, the x and y values, could be negative. So I'm going to call that 10. Now, I have a triangle. That triangle with an angle, I could do a bunch of ways. I know the sine of A is the y coordinate over the radius. Now, in the last video, the radius was 1 because we worked on the unit circle. But now the radius isn't 1, it's 10. So the y coordinate over the radius is 8 over 10, which I can reduce, I guess, to 4 over 5. That's the sine of A. The cosine of A is the x coordinate over the radius, x over r. The x coordinate is -6. The radius is 10. That's -3 over 5. The tangent of A is y over x. The y coordinate is 8. The x coordinate is -6. It gives me -4 over 3 if I reduce. And then the other 3, cosecant of A, well, that's the reciprocal of sine, 5 over 4. Secant of A is -5 over 3. Cotangent of A is -3 over 4. There they are. Those are my 6 ratios for the trig functions. That's it. So what we're doing is if you're working with an ordered pair not associated with an angle on the unit circle, you are going to make a triangle on your own. And then we can use the same definitions that we just used. It's just that the radius is not 1 anymore. Technically, you also could have done this problem with SOHCAHTOA, right? Just so you understand, they are the same thing. If I did the sine is opposite over the hypotenuse, opposite is 8, the hypotenuse is 10, 8 over 10. Cosine is adjacent over hypotenuse. Adjacent, -6. Hypotenuse, 10. -6 over 10. Tangent is opposite over adjacent. -8 over -6. Okay? You could do it that way as well. There's nothing wrong with that. It does the same thing. All right? I tend to think this is a little easier, the y over r, x over r, y over x. But there's nothing wrong with using SOHCAHTOA to do it. It's literally the same exact thing. It's the same exact answer. Okay? SOHCAHTOA is just used for triangles floating out in space. We tend to use these definitions because you're literally on the coordinate plane, and we talk about x and y all the time on the coordinate plane. All right, so let's try another one. Let 5, -3 be a point on the terminal side of angle A. So let's draw that. So we'd have to go right 5 and down 3. So right 5, down 3. Make a point. Now let's draw out here. This is the terminal side, there. And from there, we can make a triangle. There's my triangle. I'm going to call this angle A. I know that I have to go to the right 5 units. I have to go down 3 units. And again, we're on the units, or we're on the, not the unit circle, we're on the coordinate plane. So negatives and positives count. So we're actually going down 3. We have to call that -3. And now I got to find r, the radius, the hypotenuse, the third side. Okay, so I could do that with the Pythagorean theorem. I got 5 squared equals -3 squared equals r squared. So 25 and 9 is r squared. R squared is 34. So r equals plus or minus square root 34. But the radius has to be positive. So we're going to throw out the negative answer. We're going to say r is the square root of 34. Now, I want to find those 6 trig functions. Let's start with the sine. The sine of A. Sine is the y coordinate over the radius. Y is -3. R is square root 34. Multiply top and bottom by square root 34 to rationalize. You have -3 root 34 over 34. Again, don't multiply the two 34s. Square root times the square root, it knocks each other out and just leaves you with 34. Cosine of A, x over r. So that's x coordinates 5. The radius is square root 34. Multiply top and bottom by square root 34. You get 5 square root 34 over 34. Tangent is y over x. And y over x, the y coordinate is -3. X is 5, so -3/5. And then our reciprocal functions, the cosecant of A, I need to find the reciprocal of sine, but I don't want to find the reciprocal of this one here. I don't want the reciprocal of this one because it puts this radical in the bottom. I want to find the reciprocal of this one. That was the original answer because it puts my radical on the top. So I get negative radical 34 over 3. Same thing with cosine. I want to find the reciprocal of this one because it puts my radical on the top. Square root of 34 over 5. And then the reciprocal of tan is -5/3. And that's my answer. That's all 6. Okay. Again, it works with SOHCAHTOA as well if you want to do it that way. As long as you draw your triangle correctly and put the angle in the right spot, it doesn't matter which way you do it. All right. Now, one of the things that maybe you did notice, maybe you didn't, is that the signs of the x and y coordinates change depending on which quadrant you're in, right? Now, we all know that, okay? If you're on the coordinate plane, right, here in quadrant 1, they're both positive. In quadrant 2, the x is negative, the y is positive. In quadrant 3, they're both negative. And in quadrant 4, the x is positive, but the y is negative. But what we can do is, since we know that, and we also know that the trig functions, so the sine of theta is like y over r, cosine of theta is x over r, and tan theta is y over x. We know that the radius of the circle, no matter what, has to be positive. So The sine depends simply on the y coordinate and the x coordinate. So for example, if I look at quadrant 1, in quadrant 1, both the x and y coordinate are positive. So that to me means the cosine is positive because cosine's x. The sine is positive because it's y. And tangent will be positive because it's y over x. So all of them are positive in quadrant 1. In quadrant 2, the x coordinate is negative. So the cosine is negative in quadrant 2. The sine is positive in quadrant 2 because it's the y coordinate. And the tangent, y over x, is also a negative. So only in quadrant 2, sine is positive, just the y coordinate. In quadrant 3, sine, the y coordinate, is negative. Cosine, the x coordinate, is negative. But tangent is y divided by x. Divide the two negatives, you get a positive. So tangent is positive in quadrant 3. And then in quadrant 4, the x coordinate's positive, that's cosine. The y coordinate is negative, that's sine. And then tangent is, you divide the two, that's going to be negative. So cosine is going to be positive in quadrant 4. Now the reciprocal functions also hold, right? If sine is positive in quadrant 2, so is cosecant. If cosine's positive, so is secant. If tangent's positive, so is cotan. All right? But what we're going to do now is we're going to use this concept. Some people remember this. They're all positive in quadrant 1. Sine is positive in quadrant 2. Tan is positive in quadrant 3. Cosine is positive in quadrant 4. Some people remember this as all students take calculus. Okay, they're all positive in quadrant 1, sine in positive 2, tangent positive 3, in quadrant 3, and cosine in quadrant 4. All right, so we're going to play a game. We're going to play Name That Quadrant that satisfies the conditions for the given angle. All right, so let's show you how this works. This is not that complicated. It looks way more complicated than it actually is. In letter A, I want you to find for me the quadrant where the sine is negative and the cosine is positive. Okay, now before we do this, let's make sure everybody knows. The quadrants go in a C direction. Quadrant 1 is in the top right, 2 is in the top left, 3 is in the bottom left, 4 is in the bottom right. Okay, they make a C. 1, 2, 3, 4. You got to know that. All right, here we go. Sine is negative, cosine is positive. Okay, remember, sine is the y coordinate, cosine is the x coordinate. So I'm asking you, in which quadrant is the sine, the y coordinate, negative? If the y coordinate is negative, then it's not that one, and it's not that one, right? Because the y coordinate's positive here in 1 and 2. If the x coordinate is positive, well, it's not that one because the x is negative. So you must be here in quadrant 4. That's the answer. So we're going to do this by process of elimination. We're going to eliminate answers till there's only one quadrant left. Okay? Letter B asks where the tangent is positive and the sine is negative. The tangent is the y divided by the x, and the sine is the y. Okay. We're going to go for sine is y first. So let's come over here. Sine is the y coordinate. The y coordinate has to be negative. So it's not there. It's not in 1, and it's not in 2. The y is positive here and there, so they're not right. So it's either 3 or 4. Now, if I divide the y by the x, I have to get a positive. In quadrant 3, both of the coordinates are negative. Negative x, negative y. In quadrant 4, the x is positive, the y is negative. So if I do a negative divided by a negative, I get a positive. That's what I want. So then that's the quadrant. I'm in quadrant 3. And then for C, I want the cosecant to be positive and the secant to be negative. Okay, rather than using secant and cosecant, we can use their reciprocals. So let's do sine and cosine. Sine is the y coordinate, cosine is the x coordinate. Here we go. Sine y is positive. So where's the y positive? Well, the y is positive there and there. So those are both could be the answer. The cosine is negative. X coordinate's negative. So it's not there. It must be here. X is negative, y is positive. That's quadrant 2. That's the answer. Okay? You're going to be expected to do this. Recognize the quadrant, because what we're going to do is we're going to build triangles in the quadrant that you're expected to recognize. All right, here we go. I'm telling you that the tangent of theta is 5 over 12, and sine of theta is less than 0, and I want the other 5 trig values. All right, what we're going to do is we're going to make a triangle. You know you need to make a triangle because the 5 over 12 is not on the unit circle. Think about it. Is there any way to get 5 divided by 12 using any of the points that are on the unit circle? No. No way. It's impossible. So 5 over 12, okay, not on the unit circle. I'm going to have to build a triangle for it. But the first thing I need to decide is what quadrant am I going to build that triangle in? So we have to name that quadrant. The y divided by the x is tangent. The answer is a positive. So I know y divided by x is a positive answer. And sine is negative. So the y coordinate is negative. Okay, so let's come down here. Here we go. The y coordinate's negative. So it could be in quadrant 3. Well, it's not. I know it's not here in quadrant 1 or quadrant 2, right? Could be quadrant 3 or quadrant 4. Y divided by x is a positive. Now remember, in quadrant 3, both coordinates are negative, left and down. In quadrant 4, right and down. So one positive, one negative. Now the answer has to be positive. So I must be in quadrant 3. Okay? I know now I'm in quadrant 3. Now what I'm going to do is I know the y coordinate is on top and the x coordinate's underneath for tangent. The y coordinate's 5, the x coordinate's 12. So I'm going to build a triangle in quadrant 3. Here we go. There's my triangle. I built my triangle. The y coordinate is 5, but it's really important to know what quadrant to build the triangle in because my y coordinate is 5, but I'm going down 5 on the coordinate plane. So that's actually negative 5. My x coordinate is going to the left 12. So that's actually negative 12. The radius is what I don't know. But I could find it with the Pythagorean theorem. Negative 5 squared plus negative 12 squared equals r squared. R squared will come out to be 169. I take the square root on both sides, and the square root of 169 is 13. So r is plus or minus 13. But I'm talking about the radius, so it can't be negative. Talk about radius of the circle. R has to be 13. Now, I have a triangle. Here's my angle theta. I want to find the other 5 trig values. So I want to find the sine of theta, the cosine of theta, the tan of theta, the cosecant theta, the secant of theta, and the cotan of theta. Well, I can already do 2 of them. Tangent is 5 over 12. That makes cotan 12 over 5. Now I want the sine of theta. Sine is the y coordinate over the radius. So the y coordinate is negative 5. The radius is 13. Negative 5 over 13. The cosine is x over r. X is negative 12. R is 13. Negative 12 over 13. Cosecant is negative 13 over 5. Cotangent is negative 13 over 12. And that's my answer. There's the 6 of them right there. Okay? So we're using what we just did in the last slide and what we did in the previous slide to come up with a new way to build a triangle. So you're now figuring out where the triangle actually belongs. Here we go. Given the secant is negative root 7 over 2 and sine is greater than 0, give the other 5 trig values for theta. Okay, so again, I'm not told where to build the triangle. I'm just told one trig relationship and that sine is bigger than 0. Well, I know sine's the y coordinate, so I know the y coordinate's got to be positive. All right, let's see if we can figure out where to build this triangle first. Y coordinate's positive, so that's up here. So it's not there, and it's not there. Secant is the reciprocal of cosine. Cosine is the x coordinate. The x coordinate here is negative. The answer is negative. So where's the x coordinate negative? Over here in quadrant 2, not in quadrant 1. It's positive there. So I'm going to build my triangle in quadrant 2. There's my triangle. I'm working with the secant. You can flip the secant over and do the cosine if you want. That was negative. Or you can just do it with secant. Secant is the radius over the x coordinate, r over x. All right, now I got one negative here. I need to know where to put the negative. Well, I can't put the negative on the radius. So the radius has to be positive root 7. It can't be negative because it's a radius. The x coordinate must be the negative one, negative 2. Yeah, that makes sense because I'm going, look at my triangle. I'm going left. So my x coordinate is, in fact, negative 2. But I don't have the y coordinate. I could find it, though, with the Pythagorean theorem. Negative 2 squared plus y squared equals root 7 squared. So that's 4 plus y squared equals 7. So y squared equals 3. Take the square root. Y equals plus or minus square root 3. Now, I got to make a decision. The y coordinate here, I'm going up on my triangle. I'm going up. So my y coordinate must be a positive. So this is root 3. If we were going down, your y coordinate would be negative. Okay, because we're working now on the coordinate plane. All right, now find the other 5 trig functions. Okay, well, here's my angle theta, sine theta, cosine theta, tangent theta, cosecant theta, secant theta, I already know, it's negative root 7 over 2, and then cotan theta. So secant theta is negative root 7 over 2. That makes cosine negative 2 over root 7. Rationalize it. Get negative 2 root 7 over 7. Sine is the y coordinate over x. Y over r. Y over r. Y over r. The y coordinate is root 3. The radius is root 7. So I got to multiply top and bottom by root 7. That's root 21 over 7. Can't reduce the 7 into 21. 7's outside the radical. 21's inside it. And then we have tangent is y over x. So that's going to be root 3 over negative 2. Okay. Now for cosecant, well, it doesn't matter which one you flip over. You're going to end up with a radical underneath. So I'm going to flip over the first one and multiply top and bottom by root 3. It gives me root 21 over 3. And then finally, cotangent, I'm going to flip that over. Flip over tangent. Multiply top and bottom by root 3. And I have negative 2 root 3 over 3. And that's my answer. Those are the 6 trig functions given this ratio and that information to help me to figure out which quadrant to build my triangle in. So what you need to take from here is you need to know that those same definitions, sine is y over r, cosine's x over r, tan's y over x. You need to know if I give you a point to work with on the coordinate plane, you can build a triangle and use those definitions to find the 6 trig functions. You need to know how to determine which quadrant an angle is in based upon the information that's being provided to you. All right, so to eliminate other quadrants to get the last quadrant, and then you need to be able to combine those two things into this, where I give you one ratio and some other information to help you figure out what quadrant to build your triangle in, build your triangle in that quadrant, and then find me the 6 trig functions. Okay, and that's it. And as always, thanks for clicking.